All right, so today we're going to be talking about quadratic regression. So we want to look at some real world scenarios and apply them to quadratics. All right, so you can go ahead and read this, but basically what it's saying is we're going to be doing the regression in Desmos. So we've learned about the line of best fit or regression when we did linear. And if you recall, linear when we did Desmos is y1 tilde mx1 plus b. Okay, so based off of the linear equation y equals mx plus b. Now what we're going to do is regression for quadratics. And here's our formula for quadratics. Y1 tilde ax squared 1 plus bx1 plus c. Now, it's similar to standard form, y equals ax squared plus bx plus c. The only changes, remember, that we do on regression is we change our y's and our x's so that they have ones. And the other thing you change is your tilde instead of an x sign, or excuse me, instead of an equal sign. What is going on? Sorry. Okay. All right. Desmos steps for quadratic. Enter the data into the table in Desmos. Enter the expression y1 tilde ax squared 1. By the way, if you put ax1 and then the square, it won't matter. It'll automatically put it in the right location. Plus bx1 plus c on Desmos. Then you're going to find A, B, and C. So that will tell us that information on Desmos. And then using that, we can write our quadratic equation and substitute to answer any questions they may give us. When you type in the regression, just like when it was linear, you found out the correlation coefficient, which was called R. So R is going to be our correlation coefficient for linear. R squared is quadratic. So remember, the square means regression for a quadratic. As a reminder, anything close to -1 is meaning it's a strong perfect, and all the way up to a +1, which means a strong perfect or a perfect positive. And then anything in between from weak, which is close to 0 or less than 50%, to strong or negative to 50% is weak, and then over -50% up to 1 would be considered strong, weak, strong negative. So we're going to use that to see how strong our data is. All right, so fitting a quadratic function into data. Use technology to find A, B, and C and let X represent the data size in megabytes and let Y represent the runtime in seconds. So they gave us some table. Similar to linear regression, we can run a regression with quadratics as well. This will allow us to forecast future outcomes based on previous events. So we can type that into Desmos as a table. So here I've already done it for you, just so you can see when you do it on your own, x values and my y values, it creates my parabola. I type in my regression formula, y1 tilde ax1 squared plus bx1 plus c. It will tell me my correlation coefficient. It will tell me my a value, my b value, and my c value. This is nearly perfect. So this is a strong positive correlation coefficient. So my data is pretty strong. So it's pretty close to being perfect quadratic. My A value, my B value, and my C value so that I can write my equation. All right, it says using the function estimate the runtime to analyze 3.5 megabytes of data. So we want to make sure we write the equation and then we're going to input 3.5 into the equation. So we're going to look, where was 3.5 on the table? So 3.5 was our megabytes or gigabytes, excuse me. So that's my X value. So X value is 3.5. I don't know why it says megabytes, it should be gigabytes. Anyway, 3.5 is the X value. So we're going to type in all of our information from here to create our equation. It doesn't tell us how to round, so normally we round either tenths, hundreds, or thousands. So since it didn't say how to round it, we're going to round to the thousandths place. So our A value, our B value, and our C values to the hundredth, so we'll leave that one as is. And then we'll substitute in the X value, and instead of X, we'll put 3.5. So I've done that here. So I have 0.514, that was the A value to the nearest thousandths. 3.5 is my X value squared plus 0.594 and then X. So I input my X value plus the C value of 0.16. And I get my answer, which is about 8.5. So that will be about 8.5 seconds for it to run 3.5 megabytes. Okay. Predict the runtime for 10 megabytes. So this time my X value is going to be 10. So we're going to use the same exact equation, rounded to the nearest thousand, and we're going to substitute in 10. So as you can see, I went ahead, I substituted in the 10 value into the equation, and I got 57.5. So it takes about 57.5 seconds. Okay, next one, determine the equation or line of best fit from the table. So we're going to put the table into Desmos, and then we're going to make sure it's quadratic, so it needs to be a parabola, and then we're going to write our equation. Again, you have to put in the table, run the regression, y1 tilde ax1 squared plus bx1 plus c. So as you can see, I typed in my table, and I have my correlation coefficient, my A value, my B value, and my C value. So now I can go ahead and write my equation, which I don't know if I did that on this one. Okay, so let me go ahead and write that out for you. So my equation would be y equals, or you can say approximately equals, 4x squared, because ax squared, plus 8x, which is the B value, minus 12, which is my C value. Okay. Determine the equation and line of best fit from the table. So I gave us a table, find A, B, and C, and then write your equation. So type in your table, run the regression with a formula, and then find your values for A, B, and C so you can write your equation. So I did that for you. So you can see I put in the table. I ran the regression by typing this into Desmos. It gave me my correlation coefficient, which is perfect, my A value, my B value, and my C value. So now I'm ready to write my equation. So my equation would be y equals 2x squared plus 2x minus 4, A, B, and C. Okay. Determine the line of best fit from the table. Again, they give us data for a table. Type into Desmos. Find your A, B, and C after you run a regression. So you write your equation. All right, so I typed in my table. I ran my regression. I have my A value, my B value, and my C value. This is a perfect positive for correlation coefficient. So my equation is y equals, I don't need to put 1, so x squared minus 5x for B, and then C, which is 4, so plus 4. And there's my equation. Okay. What happens when neither the linear or quadratic correlation coefficient equals 1? Look at the graph. Is the trend line curved or is it linear? What is the equation? What's a correlation coefficient to the nearest hundredths? And what's the strength of the correlation coefficient? So first thing first, we're going to type in our table into Desmos. Secondly, we're going to type in our regression so we can see if it's curved or if it's a straight line. We're going to see what our equation is based off of the A value, B value, C value, assuming it's curved, and then see our correlation coefficient, which is R squared, and we're going to describe the strength. So put in the table. I ran the regression with a formula. So I can go ahead and identify A, B, and C and my correlation coefficient. So first question is it curved? So yes, it was curved. And what is my equation? So we got y equals, it didn't tell me how to round it, so I'm going to round it to the nearest thousandths. So 1.209 x squared. Sorry, I don't have my pen with me. Plus 12.999. And then plus 504.257. Oops, sorry, I forgot the x there. Okay. And then correlation coefficient to the nearest two decimals. So it's actually would round up to 1, but for the purposes of this, I don't think we wanted to put 1. So we'll put 0.99, and then we'll just say all of it, 88. What's the strength? So we don't want to call it perfect because it's not exactly 1. So we're going to call it a strong. If we rounded it, we'd say 1, but we're going to call this as a strong positive. Okay, strong positive correlation. Okay. Carl stands at a ledge 64 meters above the ground and tosses a golf ball upward. The height of the ball above the ground is given by the table. Look at the graph. Is it linear or curved? What's the equation for the line of best fit? What's the correlation coefficient, and describe its strength? So we're going to put in our table into Desmos and run the regression so we can find the information out. Go ahead and do that. All right, so I typed in my table into Desmos. I noticed that it is curved, so I know it's quadratic. I run my regression. I find out A, B, and C, and my correlation coefficient is exactly 1. So we're going to go ahead, we're going to use this information to write our equation and describe our correlation coefficient. So my line was curved. So let's go ahead and say that was curved. My equation, so my A value, B value, and C value, I've already copied it here for you. So we got y equals, and they didn't tell me how to round it, so we're going to do it to the thousandths again. 4.906 x squared. B value, so plus 9.604 x, plus C, which is 64.000. Okay. And what's our correlation coefficient? Well, it was exactly 1. So what is that strength? Well, that's actually perfect positive. But if you said strong positive, that would be fine too, just because I will take either one of those answers. They're both strong. Okay. South Airline tracked a number of flights from Chicago to Pittsburgh from 2007 to 2014. This data is represented in the table below, where the year is number of years after 2007. So year 0, that's 2007, there are 2 flights. Year 2008, there are 4 flights, and so on. About how many flights will be expected to fly this route in 2017? So, well, we need to first find the equation so we can figure out how many flights. So the first thing you're going to do is run your regression by putting in your table and typing in the regression formula. All right, so I have my table in. It's quadratic. I've run my regression. It's near perfect. And I have my parameters for A, B, and C, so I can write my equation. Now, if you recall, it said since 2017. Well, that's not, don't put your X value as 2017. You got to figure out how many years since 2007 was that. So you would subtract 2017 from 2007, then that's 10 years. So our X value is not 2017. Our X value is actually 10, because remember, we don't use years for our X values. We put how many years since. So we're just going to type in 10 where our X values would be into the equation, rounded to the nearest thousandths because they didn't tell us how to round. And so there would be about 111 or almost 112 flights. So that would be a good estimate. If we didn't want to round up, you said 111, that would be perfectly fine because you wouldn't round up a flight. All right, hopefully that makes sense. That's all I got.